Welcome to the first lesson of the rate and extent of chemical change topic. In this topic, the key questions are 1. What is and how to calculate rates of chemical reactions? 2. What factors affect the rate of reactions? The key terms that you need to be familiar with: rate of reactions, factors affecting the rate of reaction. In today's lesson, we will talk about the rate of chemical reactions and the factors that affect it. Task. Now please pause the video and think about what the rate tells us about a reaction. Hint: rate is related to speed. Extension. How can you describe the rate mathematically? Now let's discuss these in detail. The rate of a reaction tells us how fast the reaction proceeds. In other words, how quickly the reactants are transferred into products. An important factor that affects the rate is concentration. In general, the rate of a reaction is described as the concentration change of either the reactant or the product. Rate equals change of concentration over time. For the reaction of A plus B to C. The rate is proportional to the concentrations of A and B concentrations. Instead of concentration, the rate can be expressed with pressure and volume change for gas-forming reactions. Task. Now please pause the video and think about factors that affect the rate of a chemical reaction. Hint: remember, the rate tells us how fast the reaction proceeds. Extension. How does concentration affect the rate? In order for a reaction to happen, reactants need to collide, and energetic enough collisions, minimum energy required is the activation energy, will lead to the formation of a transition state that will decompose into products. Therefore, those factors that help to increase the collision frequency all contribute to the rate of reaction. Concentration and temperature are obvious factors. However, if pressure is increased, that also leads to higher collision frequency and therefore to larger rate. The bigger the concentration, the more chance the reactants have to collide, therefore more chance to form a transition state. Similarly, for surface reactions, the surface area affects the collision frequency. Larger surface area makes the collision more frequent. The presence of a catalyst can also speed up the reaction, but it doesn't affect the collision frequency. It opens a faster reaction path.